Before continuing further, let's review some of the properties of vector addition. I am not going to prove these theorems. They simply follow from what we have learned about vector addition and scalar multiplication till now. I would encourage you to take actual examples and convince yourselves that these theorems are indeed true. So, you just have to assume that u, v, and w are vectors and c and d are scalars. So, vector addition is closed under addition. So u plus, if u is a vector, v is a vector, u plus v is also a vector. Commutativity simply implies that the order of addition of vectors does not really matter. Associativity is also very simple. You can actually take actual examples and prove it yourself. I think we did not really talk about zero vectors. So this guy in the bold zero is called a zero vector. So a zero vector is a special vector where all the elements of that vector will be zero. All right. So now you can easily see when you add a vector u to a zero vector, and this actually follows from commutativity. You will get the same vector. Additive inverse. Again, so if you add a vector and then add its additive inverse, which is nothing but scalar minus 1 times that original vector, you'll get the zero vector. Vector multiplication, scalar multiplication is closed. So if u is a vector, c is a scalar, cu is a vector. It also has scalar multiplication, associativity, and distributivity. And I think if you look at all these theorems, they kind of follow from standard algebra. So if you remember your middle school algebra, you will notice that there's a lot of similarity between what we are talking about linear algebra theorems and your standard algebra that you read in school.